Hey there, and welcome to 3D Printed FPV, where we talk about everything related to printing, building, and flying 3D printed aircraft and quadcopters. Hey, give me a subscribe or a thumbs up, would much appreciate that. I'm trying to grow this channel and need all the support I can get. All right, buckle your seatbelts. Today we're going to talk about how to tune your printer like an expert. If you follow this guide step by step with any filament, you're going to increase the quality of your prints and be printing like a champ. Most of our aircraft are printed with either lightweight PLA or mix in some PETG for stronger parts. So today we're going to take a quick look at how to tune your printer for the best quality output while using PETG. PETG is generally used for the stronger parts on the airplane. There's not a lot of PETG generally printed, but it's important to print it at a high quality. So today we're going to have a look at tuning for PETG. You can do this with any slicer, but I recommend the Orca Slicer. The Orca Slicer has some calibration tools in it that you just don't have in other slicers. It makes your life really easy to tune up your printer and get great prints. All right, so let's dive into this. All right, so let's get into this. The first thing we're going to do is start a new project via the File menu. Then we're going to select a printer that we're going to calibrate. I like to make a copy here and put a dash after it for the type of filament we're going to calibrate and use that profile. Here we're going to select the filament. This is going to be generic PETG for now. And the first step of any good calibration is picking a temperature. So we're going to make a temp tower. So we select standard quality, and you can change some settings here if you want to, but that's not really the point. We're going to do the calibration based off of the generic profile. Again, you can change filament settings here, but let's get straight to the temperature tower. First thing we want to dial in is the printer temperature for the particular filament. We're going to use PETG, as I said, but if you were doing something else, you would select a different filament here. This is where you select your temperature range. So each layer of the temp tower is going to have a different temperature it prints at. And as you go up the tower, these temperatures are going to change by the temp step of 5 degrees. So you can see now, I click the OK button there and I've created my tower. Down on the bottom, you can see the temperature of 250, I think. I can't quite read it here. And it's going to vary by 5 degrees going up, 250, 255, 260. No, it's going down. My bad. Yeah, so we're starting at 260, then we go to 255, 250, 245, 240, 235 as we go up the tower there. So as I'm going down through the layers here, you can see each of the main layer changes. So the top where you have the bridge on the temp tower is where it's going to swap to the new temperature. So right after that, it's going to go down by 5 degrees, down by another 5 degrees, down by another 5 degrees, and so on there. So we're going to go ahead and print this thing. We'll do an inspection on it after it's printed and have a look at it. We'll be looking at the bridge section there, and there's a little pyramid that's hard to see in the screen here on one side, and then the overhang and the numbers, of course, just seeing how the print quality lines up across the various temperatures. And that will dial us in for the temperature we select. After we do the temperature tower test here and select our print temperature, we'll move on to testing some extrusion testing and dial that in. But yeah, let's send this to the printer and knock out this temperature tower, and then we'll have a look at it and dial in our temperature. All right, here we're looking at the printer, and I said earlier this is a K1 Max. K1 Max with the textured build plate, and I run mainsail, so here's a look at the mainsail screen. I'm not going to put you through the pain of watching this entire print. I'm going to throw this thing into warp speed and just stop it every once in a while to show the print temperature changes and get through this in a hurry. So let's turn on warp speed. All right, welcome back, crew. We've been on warp drive there for a little bit. I just wanted to slow this down, show you the end of the first temperature range on the tower. You can see here in the time lapse, we're finishing up the top bridge there and just nailing this first layer down. I'll pop over here to mainsail and just have a look, show you the temperature and show you what mainsail is doing. So you can see up here, the top middle of the screen, we're 255 degrees. Like I said, this thing started at 260, and you can see right there the temperature change as it went on to the next layer of the first layer, I guess the second portion of the tower. It's dropped the temp down. So I always like to confirm that the temps are dropping and the printer's actually reading the G code properly and things are good to go. So I'm going to throw warp speed back on, and I will see you at the end of the tower. All right, warp speed, we are on. Look at that tower go. All right, we're near the end of this thing, and I'm going to pull us off of warp speed here, and we're going to give this tower just a few minutes to cool down in the printer, and then we're going to pull it off and make our inspections and have a discussion about each layer, and then we're going to select our print temperature for PETG. And then after that, we're going to start doing some extrusion testing and get this printer fully dialed up for PETG. All right, let me pull this thing out and let's give it a look. All right, we've got our temp tower out here in the workshop. Just going to have a look at this thing and select our printer temperature to calibrate to, and then we'll run our extrusion test. If you look at this thing closely, you can see the little pyramids in there and how they're built up, and you can see the bridging and how far that's went with each one. You can see 235 there's clearly not nice there on the ceiling part of the bridge. 240 is not looking too good either. 245 you're starting to get some actual adherence there. 250 is starting to look better, but you can see 255 is if I can get the light to reflect properly, actually pretty solid. And I start looking at the rest of 255, and you can see the tips of the towers here starting to break down and not print after you get lower than 250. And 260 looks like there's like a little bit of warping out here on the edge. And if we just look at the surface finishes and then the numbers actually in there, probably 255, 250 looks the best on those. The overhangs out here on the end, you can see definitely 255 is pretty solid. 260 is pretty solid. 255 is pretty solid. Then from there you start getting a little bit of like stringing and some extrusion issues, but they all look pretty good, to tell you the truth. So I'm thinking we're going to stick with 255. I like the looks of that here on this particular test, and I believe that's what's also recommended by the filament manufacturer. All right, crew, we are back over in the Orca Slicer, and let's set that 255 temp in the filament profile. First thing you can do is click on that pencil icon there to edit the filament profile. You're going to scroll down a bit until you find print temperature, and you're going to set the first layer to 255, and then you're going to set other layers to 255 as well. Then you're going to hit the save button. What I like to do is actually put a dash and then some type of reminder that I've edited this profile in some way. So I'll normally do like dash tuned or dash and then some note to myself over what I've done to the profile, just so I know to select that one the next time that's the best one. Normally hit OK here. I'm going to hit cancel since I already have a profile, but that's how you save your 255 into the system. Let's get back over to the build plate and make ourselves some extrusion tests. All right, crew, let's get back over into Orca and do these flow rate tests. First thing we're going to do is clear the build plate, of course, because the flow rate tests are a different test article than this temp tower. So let's delete that, get rid of that. Let's run through our printer settings here real quick, just make sure that we've got the proper build plate selected, which I don't. I've got a textured build plate. You should have that new profile if you saved a new profile here where we have the filament profile. So if you added like dash modified or dash tuned, make sure you select that, and then you'll get your 255 degree printer temperature or nozzle temperature that we put in just a few minutes ago. You can see here for sure I've got the right one selected because I've got 255 degrees in here. This is what our temp tower said was our best printing quality, so we want to make sure that that is here when we do our flow rate tests. Otherwise, this whole calibration process is for nothing. So let's go up here. Let's say flow rate. Let's do pass 1. It's going to generate the test articles. So what are these test articles? These test articles are a flow rate test. So you can see that one there in the middle is 0, and then we go around clockwise there, and we go up 5%, down 5%, left and right. So all the way to plus 20% flow and minus 20% flow in those 9 articles. So let's go ahead and slice this thing and send it to the printer. And I'll turn on warp drive for the print and keep that short, and then we'll get right back into the inspection of pass 1 here on the flow rate tests and how we tune the filament profile for what we learn out of this flow rate test. All right, warp drive is coming up, and I'll see you on the other side. All right, you can see the printer working away here and doing the 9 test articles. As I said earlier, each one of these test articles is a different flow rate. So you might actually be able to see some different surface finishes, maybe some blobs, or under extrusions in this print, but let's inspect it. Yeah, so here we go. I've got the samples out. And again, this one here in the middle is the 0, -5, -10, -15, -20, and then go in the opposite direction. We've got the +5, +10, +15, and +20. I'll move this around a little bit just so you can see the light striking these guys here on the plate. If we look at 0, 0 actually has a pretty nice finish to it. Not looking bad. -5 perhaps has the best looking finish. It's not over extruded, it's not under extruded. The surface is nice and smooth in both directions. If we keep going, -10's obviously looking a little rougher. -15's definitely rough, getting some under extrusion there. And -20's, you can see the under extrusion all along the edges for sure. So if we go the other direction and go from 0 to 5, it looks like we get a little bit of surface roughness there. Probably getting a little bit of over extrusion. And then by the time you get to 10, it's clear. I mean, I can run my fingernail on here, and you've got raised ridges everywhere, and you're starting to get some like blobs like around the edges. So then 15 continues to get worse, and then 20 continues to get worse. There's really some like raised edges there from that extra material coming through the print head. So yeah, for the PETG calibration here, it seems to me that either 0 or -5 is going to be the number. They tell you to go with the higher of the two settings. But just for fun, we're going to go with -5 here for this, and do the math on -5, adjust the printer, and then run the second pass of plates. All right, crew, back with you here. Let's figure out how we're going to adjust our printer settings. It's based on an equation. You're basically doing some math here to adjust the original setting by the percentage of either under extrusion or over extrusion. Don't worry if you suck at math. I'm going to put this equation in the description of the video. You can copy it and paste it into Excel. You just have to make sure and use the E column and get it in the right spot. So the first one is our original setting. Next box there is our best sample. That's what we just determined was -5. And then it's going to automatically calculate our new setting there. And that's what we're going to put back into the Orca Slicer profile. So there's the equation. I'll have that down below. That's basically just changing the original setting by whatever percentage of over or under extrusion we saw in that previous little segment of the best test article. Okay, so let's do the math here, and let's get back over and stick this into Orca in the filament profile or the printer profile, wherever it belongs. And like I say, right there, that is the new setting for your printer. That's going to adjust your overall printer to match the extrusion rate we saw in the best article that we had there earlier. All right, we're back over in Orca now. We're going to go ahead and click on that PETG profile. This needs to be the same profile that you modified before with the temp. And we're going to go down to flow rate, which is right at the top there. Put in 0.95, save this thing. And let's not rename it this time. We don't want to rename it. That should still be your modded or tuned profile. Just overwrite that. So next we're going to go ahead and clear the build plate. We're going to go back to calibration, flow, and do test number 2. So if you remember, we were doing plus and minus 20% on the last go around. This time we're only doing plus and minus, minus actually only down 9%. So there's a 0 all the way down to -9. This is why it tells you to select the higher of any of the best, or if you can't make a decision in the previous test when we inspected things, because it's only going to reduce downwards from here. So let's go ahead and print this. Warp drive on. All right, crew, let's get back at it here. Warp drive is almost over. This second set of test articles is almost printed. And let's take a look at these and see what we're going to do for printer adjustments. You can see here, everything is pretty solid. There might be a little bit of under extrusion down towards the 8s and 9s there, maybe 7, but for sure, like 0, -1, -2, -3 are darn solid prints. In fact, I feel like 0 might be the best one out of this whole batch. -1. So I'm going to go ahead and leave this thing at 0 for my printer, but you need to do the math here and do whatever is best for your outcome. So how to do this, you go back to that same spreadsheet again. You're going to put 0.95 in as the current print setting, or whatever yours was, and then you're going to put this in the second row for whatever the best number is here, and whatever comes out the bottom, which is going to be very close to the original number, you're going to put that back into Orca Slicer just like we did in the previous segment here. I'm not going to show you how to do that again. I think you can probably figure it out on your own. So from here, you are going to be printing pretty excellent prints, but we're going to dial it up one notch. We're going to look at the pressure advance and then also the retraction settings and do testing on those, and we will have you absolutely dialed up. All right, crew, here we go on the next calibration. This is a feature called pressure advance that we'll want to calibrate. If you don't know what pressure advance is, Google it online. In short, it is a calibration that allows us to slightly increase or slightly decrease the extrusion rate as the printhead speeds up or slows down. So as the printhead slows down, before and during the deceleration, we reduce the flow rate a little bit, or during a fast acceleration, the pressure advance will increase the flow rate to keep up with the acceleration. So this is like dialing in, the print quality. It's definitely a good feature. You need to have a look at your firmware and your printer and see whether this is supported by your firmware or even your slicer. But yeah, let's get into the calibration on this. So what we're going to do is go back to our calibration menu. I've got a clear build plate here, as you can see, and I've got the standard stuff that we've been working with there on the printer and filament and process settings. So I'm going to go to pressure advance here, click pressure advance. It's going to throw up the next menu. First thing we have to do is select our extruder type. DDE stands for direct drive extrusion, and Bowden, meaning that your extruder is generally mounted like outside of the print area, generally like on the side of the printer, but not on the print head. So I've got a direct drive extruder, so we're going to go with that. And the first thing we're going to do, we're going to run both the PA pattern and the pressure advance line test. First thing I'm going to do is run this pattern test and have a look at this. So I'm going to hit OK here. And I don't know why, and you want the changes that the test wants, not the changes that you had in the settings. So I don't know why Cura does this, but the first thing you get is this strange little cube, and you're like, oh wow, calibration menu didn't work, and it didn't make my test article for me. But if you go ahead and slice this thing, you end up with your test article. So
you can see here what the printer is going to do and lay out. And then basically it's going to increase the pressure advance, um, as you can see there numerically, which we'll get into where to set that thing up as it accelerates through these lines. So it you'll see in the video kind of goes slowly on one, then like starts the acceleration, which then uses the pressure advance. So let's go ahead and throw this thing to the printer and we'll let it print and then we'll make an inspection of it.
All right, crew, back with you here. I've had warp drive on, and yeah, this pattern pressure advance test article is almost done here. And we'll be taking this off the printer here shortly and making an inspection on it. So what we're going to be looking for is nice, tight corners on it, no blobs or goop or over extrusion in areas, and no under extrusion in areas. So we'll be looking at the bottom of that V section closely, and then both sides of the arm of the V leading down to the actual radius itself. So let's have a look at this thing here. It actually looks really good across all the different settings. You know, I'm looking at this thing, you see just a little bit of improvement as you go down and pressure advance is increased. The top of it is 0.01 pressure advance, and the bottom of that thing I think is 0.09 pressure advance. Honestly, the 0.3, 0.03, 0.04, 0.05, something through there is looking the best in this test article. But let's not make a decision on this. Let's run the next line test and then select the best of both worlds for our actual pressure advance setting that we're going to put in the computer. All right, so let's get our line test ready and run that.
All right, crew, back with you here. Now that we've inspected our first test article, I'm going to go ahead and run the other pressure advance test. So no drama here. Simply come over, get on the back on the prepare, and clear your build plate. And go to calibration, pressure advance again, and this time let's take PA line. So pressure advance line. Make sure DDE or Bowden is selected based on what your printer type is, and click OK. And let's not transfer the changes we want to discard. And again, like I said with the other test, does this like weird thing. You're like, oh man, where's my test article? But as soon as you slice, you end up with your test article. So let's talk about this one real quick. This is very similar to the last little pattern test we ran. You can see the pressure advance settings here, and you'll see in the print, this thing that starts to accelerate across this line at one speed and then changes speeds. And basically, the connectivity of the lines changes as we look through here. Some of these lines will be like super ragged, and some will be like wide and then small based on, you know, overpressure advance. So what you want is the number through here that has the most consistent line all the way across. So that print head's literally going one speed and then starts to accelerate, and whatever pressure advance matches that acceleration the best based on the number out here is the one that we want to select and enter back into our slicing software. So I'm going to go ahead and slice this guy, which I already have, and send it off to the printer.
All right, crew, back with you here. This line test is finished printing, and let's inspect this test article. So you can see the globs there starting at the bottom on these lines coming across. Right through there, you're starting to get into some pretty solid lines. Right there, you start getting globs again as we go down the test article. So yeah, don't like any of those lines. Don't like those. Definitely some issues there, but you can see if we start going back up right here in the 070, 068 range, we start getting some really nice lines with no gaps, no over extrusions, no things like that. So let's go ahead and select the 070, 068, something like that from this test article. And if we remember in the past test article, we thought it was going to be 0.04, 0.05, 0.06. So we're not too far off. I always like this line test better than that pattern test and find this to be a lot more accurate. So let's go back and put these settings into our slicing software and then continue to the last test.
Over here in Orca, and when we inspected our test article, we came up with the fact we wanted to put in about 0.068, maybe 0.072 for our pressure advance setting. So to do your pressure advance setting in Orca, you come over here, it's under the filament settings. You click the pencil for the filament, and it's about midway down here. You can see under basic information, you get into flow ratio and pressure advance. First thing you have to do is click the enable button. So now we've got it enabled, and we've got 02 in here, and we wanted to say 0.68. So I've done that. I've enabled it, put in 1.068. I'm going to have to hit the save button. It wants to do a copy, and I'm going to do that, and I'm going to say with PA. So now I've got a generic PETG profile with pressure advance and all the other changes that we've made in this video. This is going to help out my PETG printing just a wee bit more. I didn't have pressure advance turned on, but I do now. Okay, so that's that. We're going to come back and run one more test before this printer is completely dialed up for PETG. That next test is going to be another one you find in the calibration menu for retraction. We're off for the last test here on our calibration of this printer for PETG, and this is going to be a retraction test. Retraction is generally not too much of a problem with PETG, but if you're printing lightweight PLA, this is a huge step in getting your printer set up properly. So the first thing we're going to do is make sure we're over on the Prepare tab. We're going to clear our build plate. We're going to go to Calibration, and we're going to do retraction test. So that's going to bring up this dialog box. What this is basically how much retraction we're going to test. For PETG, this is fine. For other filaments, you need to look at what the manufacturer is recommending and start at 0 and go just a little bit beyond what the manufacturer is recommending for retraction. And then Orca automatically selects 0.1 millimeter per millimeter. So this basically means as we go up this test article, it's going to start increasing the retraction by 0.1 millimeter per millimeter that we go up this tower. I'll explain that here after I click the OK button. All right, so it generated the test article, and how this test article works is the print head comes over on one side and then the other side, and then you can see the little ribs there per millimeter going up. Let me hit the preview button and explain this thing. So down here, we're going to start with the minimum retraction, and then each layer change that has like the rib on it there is going to change the retraction amount, increasing it. So with PETG, again, this isn't a huge ordeal, but with something like lightweight PLA that strings super easily, this test is perhaps one of the most powerful tests that you can run to really get your prints dialed up. All right, that's it. I don't expect too much data or setting changes to come out of this print, but it's good to show. And like I say, if you're doing another material that strings a lot, like some of the foaming stuff or just lightweight PLA or some of the woods and other things, this is definitely a powerful test. You can check out some other videos where we run this test on lightweight PLA and just see the amount of stringing. But let's go ahead and send this to the printer and wrap up our calibration for PETG.
We're nearing the end of the print here, and I just want to take a moment to discuss why this retraction test is so important. Here, I've put the time lapse back into real time, and you can see the speed of the print head on this K1 Max. The travel speed is extremely high. I think I actually have the travel speed turned down just a little bit, but you can see here it just is unbelievably fast between the two towers. And that's why this retraction test is so important. When you start printing filaments that want to string on you, this like big jerk over to the other tower will tend to leave a string behind. And the good news is here is we have zero string. So this is, turned up to be a wonderful test. Like I said, I didn't expect any stringing here, and there won't be any updates to the print settings based on this. But we will get out the test sample and go through it and just talk about how you would read it if there was stringing, and where you would input the settings back into Orca. All right, let's pull this thing out and make our inspection. All right, let's take a look at this test article here. Like I said, there's no stringing on this thing, but if you did have stringing, what you do is you count the number of ribs that you have up to where the stringing starts going away as retraction increases. So you can feel those ridges, and each ridge is going to be one of the proportions that you selected there in the calibration menu. So you just calculate what that is, where your stringing gets better, and then insert that back into your slicer. Let's go have a look at how we insert this into the slicer.
We're back over here in Orca, and let's look at how we put in the retraction rate that we just found on the tower there. You come to your printer settings. It is a printer level setting. Click on the edit button there, and then it's under extruder. So go to extruder, and you'll see retraction. And you simply put in the retraction length that you calculated based upon which ridge had the best extraction on that tower that we just printed. And that's it. You hit the save button. I do like to rename my base printer with the filament name in it, just so I know that I've changed the retraction settings for that particular filament. But that's it. So from here, we are off into the races. Let's print a overall test article. It tests overhangs, it'll test our sizes, and do some other neat things that we can inspect and see how much we've upgraded this printer. All right, crew, this is the last step here. We just want to see how well our printer's performing. So I've downloaded a all-in-one 3D printer test, the micro version from Thingiverse. I'll throw that link down in the description here. You can see I've just thrown it on the build plate. We're going to have to rotate it and get it set up properly. So there we have it. Yeah, so this is a nice all-in-one test. I really like this test. So it gives you a couple holes here, and then shows you the inside and outside dimensions. This is great for picking off tolerances, especially on these 3D airplanes that have carbon fiber tube spars. Getting this number dialed in sets you up for success when you try to insert your spars in the wings. You've got a couple pyramids here. Those are going to show how well we're doing extrusion-wise and stringing-wise. And then we've got some other tests over here for gaps and whatnot. And then, of course, the overhang test. So you've got two different overhang tests. One goes to 80 degrees. The other one goes to 75, a little bit quicker. And then you've got some bridging tests in here, too. Anyway, this is going to show the overall health of our printer. This thing in the directions says that it's supposed to be printed at 30% infill. So I'm going to go over here and do 30% infill and do that number. And then I'm going to slice this guy. So it's all sliced up. It says it's going to take 54 minutes to print on my printer. Oops, I see I've got a mistake here. I've got support enabled, and I should not have support enabled here. So I'm going to go ahead and click and disable support. And I'm going to slice this bad boy one more time, and slice is complete. So there we go. Take one look at this just so you can see how it comes together and how it will stress the printer. So in here, obviously, nothing major there. There come the two round geometries that will give us the ability to dial in our spars for the airplanes. Then we start getting into some bridging and stringing tests there between those towers. And then we start getting into the overhang tests here. So that's it. I am going to send this thing off to the printer, and then I will make a final inspection of this thing and check the geometries, and then we are off to 3D printing airplanes. All right, crew, let's look at this final test article. This thing turned out real well. I haven't taken the brim off of it yet. I'm not going to bother. So yeah, let's look this over and have a real good look at our tuned up printer. You can see the pyramid test turned out real nice there. Nice point on it, and no stringing between the two. and it's pretty darn sharp, to tell you the truth. I'm happy with that. These posts here, there was just a hair of stringing there, but it's not even connected. So not really a problem. They're all nice and square. They look solid. I'm super happy with those. Our bridge testing, you can see the bridge testing turned out real well. There's basically good bridges on all those, with the exception of this last one. It's okay. Just has a wee bit of kind of sagging on that initial layer coming through. Then you can see all these geometry tests over here turned out well. We could measure those if we wanted to. We'll skip that for now. But I was super happy with the looks of those. Probably gonna have a hard time doing this with one hand, but I measured this earlier. I've got the calipers on here, and that's off by less than 2/1000 of an inch. And let me see if I can get on this one as well. And yeah, that guy there. They're both within a couple thousandths of an inch, or
Yeah, about 0.05 millimeters, I guess that would be. I also measured the inside diameters, and they're just about the same. That's well within tolerance to get your wing spars put in.
yeah, not horrible there as far as that goes. So yeah, overhang tests. You can see they both printed successfully and look good. If we look at the backside of the overhang test, you can see once we got up to the 80 there, we started getting some distress there in the bottom of the print. And then once we got to 75 here on this side, there's a little bit of distress in the bottom of the print. But outside of that, boy, that's nice and shiny in there, all the way right up to the top. So super happy with that. Initial layers looking wonderful. You can see that's the bottom of the print. So yeah, overall, everything's well within specs here. So very happy.
All right, crew, give me a subscribe or a follow. I hope you learned something today on Captain 3D printed FPV. See you soon.